Now that you have your pods running, you're probably going to need to expose those to external services at some point. That means allowing them to accept connections in some fashion in your cluster or from outside your cluster. And in Kubernetes, we use the kubectl expose command as one of the ways to create a service. And we mentioned service a few times before, but let's make sure we're clear on what a service is. A service is an endpoint that is consistent so that other things inside or outside the cluster might be able to access it. So when you create pods in Kubernetes, they don't automatically get a DNS name for external connectivity with an IP address, right? You would want to do that with creating a service on top of that existing pod. Now, there's various ways besides this expose command to create a service, but let's focus on what's common. The common thing in here is that core DNS, if you remember, we mentioned that earlier as one of the core features of your control plane. That service is going to be your DNS server to resolve the names for all these things. And on top of that, for picking the IP and port and how it does that, how it gets traffic essentially to your service is the job of one of 4 different service types. And let's go through those now, and then we'll go through some examples. Let's start with the service type cluster IP, which is the default. Now, in this case, the most important aspect is that it's only available in the cluster. So this is really about one Kubernetes set of pods talking to another set of pods. And this gets its own DNS address, right? So that's going to be the DNS address in the core DNS control plane. And it's going to get an IP address in that virtual IP address space inside the cluster. And that allows your other pods running in the cluster to talk to this service using the port of the service. So if you're running an NGINX app and it was running on port 80, when you created the service, that service IP could also be on port 80. So that keeps some sort of consistency there. If you think about it, this is very similar to the way when you create a service in Swarm. Now services are a little bit different in Swarm. They have a different idea around them, but they are consistent. At least when you create a service, it gives you that internal IP on the load balancer, if you remember, and it runs it on the port that the app is on. In this case, we're doing a very similar thing, but we have to create this one with an expose command or other options we'll talk about later. And the next up here is node port, which is subtly different. It is a little bit confusing out of the box. So the cluster IP is the default, and it always works inside the cluster. It doesn't need anything special. It doesn't need any firewall rules outside of the cluster for traffic to get to it. But cluster IP is only good in the cluster. So remember that. Cluster IP, good in the cluster. A node port is designed for something outside the cluster to talk to your service through the IP addresses on the nodes themselves. So when you create a node port, you're going to get a high port on each node that's assigned to this service. And once you get that, you can update other things that need to know about this port. So this port is going to be a high port. So you're not going to be able to use port 80, for example, when you use this type. And the key to these two is that they're always available in any Kubernetes cluster, whether you're using a cloud vendor solution or rolling your own Kubernetes or deploying a packaged one like Docker Enterprise or Rancher. These are the ones that will always work out of the box. Next up is the load balancer type. Now, this is mostly used in the cloud. The idea here is that you're controlling an external load balancer through the Kubernetes command line, which is pretty cool. And essentially, this is a bunch of automation. What you're doing here is in the background, when you create this load balancer, it's going to automatically create the cluster IP and node port so that those are available. And then it's going to talk to the external system. Maybe it's an AWS load balancer or some other cloud vendor. Basically, these are going to come from your infrastructure providers, and they will allow Kubernetes to talk to them through some remote API and configure them for you. So in the case of maybe an AWS load balancer, when you create this, not only is it creating those node ports and cluster IPs in the back end, but it's also telling the AWS load balancer to talk to the node ports. And essentially, this is just automation, right? This is helping you save a step from having to run some AWS command line or web interface to automatically set up that load balancer for you. So the two takeaways I have for this one are to think about it as this is only for traffic coming into your cluster from an external source, and it requires an infrastructure provider that gives Kubernetes the ability to talk to it remotely. And the last of the 4 service types is external name. Now, this is used less often, and it doesn't really have anything to do with controlling inbound traffic to your services. This is more about stuff in your cluster needing to talk to outside services, and you want to create DNS names in the core DNS system so that your cluster can resolve external names that you maybe don't have controlled externally. And one of the reasons you might use external name is when you're doing migrations of things. So think about if you have a remote application. That remote application outside of your Kubernetes cluster probably has a DNS name already, right? But if you're going to be moving, say, something from those external services to internal services, you might look at how you could use external name as a substitute to control the DNS inside your Kubernetes workflow. So you basically then could have a single command line of Kubernetes rather than saying, oh, I need to change the external DNS for something, so I have to run some other utility for that DNS service, or maybe even something that doesn't even have an API behind it, maybe like an enterprise DNS or something like that. You can use this inside your cluster so that services inside your cluster start resolving a different endpoint than the one that they previously had that was external. So I find that I really only use it when I need to change how my stuff is getting out of my cluster to some external service, but I don't have a way of controlling the DNS remotely of those other things. So I'd rather just do it inside of Kubernetes and create some external names for my stuff. Then when I want to change it dynamically in Kubernetes for my stuff inside my cluster, I can do that pretty easily without having to talk to anything else. All right, we're going to wrap up these 4 service types, but there is another way that traffic can get inside your cluster, and that's through ingress. And we will talk about that later. That's specifically designed for HTTP traffic. So when we get to that lecture, you'll understand why that's a little bit different than these service types. Now that we've talked about the 4 types of Kubernetes services, let's create some from the command line. Now, first, we're going to need to create a deployment that we can point these services to, and then we'll create different types of services to point at this deployment. In this demo, we're going to create 2 different shells or different windows into your Kubernetes environment so we can see what's happening with a watch command while we're doing it with the other commands. All right, so in my case, I have 2 windows, one on top of the other. It doesn't really matter how you do that. It's just for easier use for you to see what I'm doing. And we're going to use the kube control get pods, and we're going to add a -w. This is like a watch command where it will keep running and show us over time as things change. You'll notice that this is an option on multiple different kube control commands. So we'll do that here just to see what's happening in the background. Get pods with -w. And then down my other window, we're going to create a deployment. Create deployment. We're going to call this HTTP env. And what this is using is a very simple HTTP web server that essentially when you hit it with a curl, it just spits back all the environment variables it's getting at the command line. So it's a very simple rudimentary way for us to just validate that it's working, but also to get back interesting values like the name of the pod, stuff like that. Now that we've created that, you'll see at the top that it's creating containers, and think of it more like a log where each time something changes state or the status changes or something like that, you'll see it as a new line printing down the page like a log file. And you'll see in that last line, it now shows that we have that pod running in the running state there. Now let's spin up more of these pods so that we can have more than one of these containers running behind our service that we'll create in a second. Now the scale command is useful with a deployment because it allows us to change the number of replicas in a single friendly command. And of course, with everything in Kubernetes, there are multiple ways to do this, but this is the easiest way in our situation here. All right, now you'll see that it's created 4 more pods and it's showing those there as running. And now we're going to create that service. And for that, we use the expose command. Now, in this case, we're telling it which deployment to expose and the port that that deployment is listening on. And you'll see that this doesn't change any of the pods because this is creating an additional feature that's not related to the pods themselves. This is actually going to create a cluster IP by default. That's the cluster IP type of service, and it will create that in front of the deployment. So let's check out that service we just created. Now you should see two here. The first one will be the Kubernetes endpoint, that's for the API. And then you'll see our service we just created, and its type is cluster IP. Remember, cluster IP is only usable inside the cluster for nodes and other pods to be able to access it. So this IP address we can reach, but it depends on where we are and whether or not we can reach it. And since that IP address is only accessible from either the nodes themselves or other pods inside the cluster, when you're on Docker Desktop, if you remember that this is not running on the host OS of Mac and Windows, this is technically running in a small Linux VM. So we need to run, in this case, another pod that's running on that cluster so that we can curl it. And we don't want to run a deployment with a replica set. In this case, we really just want to run one single pod. And the easiest way to do that is with kubectl run. And we're going to use an alternate generator. You might remember that from the error earlier. We'll talk about what generators are in a little bit. Now, there's a lot going on in this command, so let's break it down. The kubectl run you've seen before. The generator is the type of template we want the run command to use. We'll talk a little bit more about that in a future lecture. And so we're picking the pod template because we only want to run a pod. We don't want a full deployment with replica sets or anything. We're going to call it temp shell. And you'll notice that some of these options are similar to Docker run, and that's on purpose. One of the future goals of the kubectl run command is to act more like a Docker run command. And in fact, we'll talk later about how it's going to eventually, by default, just create a pod for you, and you won't have to use this generator option. So we're going to use the --rm here, which means once the pod stops, go ahead and remove it. The -it gives us a shell into that pod once we hit the enter command. And then --image is telling us what image we prefer. And in this case, we're using my netshoot image, which is a whole bunch of different networking and Linux utilities in it, one of which is curl. And then with the run command, we can change the CMD, or the thing that's going to run inside the container. And we do that with a space -- space. That tells the run command to stop looking at options, and that anything after the double dashes is the command to run when I execute this container. And you'll see up at the top that the temp shell pod is showing up, and now it's the status of running, and we're in the pod with our bash prompt. And something we'll talk about in a little bit is that the service name that we created becomes part of the DNS name for this service. So we can use the very similar to what we just did in Docker and Swarm, we can use the service name to get it with DNS. And remember, it's running on port 8888. And when we do that, we get back the response that I would expect. This HTTP env utility simply dumps all the environment variables on that machine, which is inside that unique pod, right? So you'll see the pod name is the host name and other Kubernetes defaults out of the box. Now that method will work for any of you on any cluster. As long as your kubectl command line can talk to the API, that command will get you into a new pod running that image inside a shell. And that's great. But if you're on Linux, there's an easier way, because the way that Kubernetes works is that all nodes and containers by default can talk to each other out of the box. The node that you're on, assuming that you're running Kubernetes on that local machine, has access to all of these private IP addresses. So you should just be able to curl the service IP. So let me get out of my shell and do a kubectl get service again. And that IP address for the cluster IP should be resolvable from your host. Your host won't know the DNS name like we did with inside the pod, because that's exclusive to being inside the cluster, but it will know the IP address and be able to access it. So you can curl the IP address :8888, just like you would for another machine on your network. The reason that doesn't work from Docker Desktop is because you're sitting on Mac or Windows when you're typing those commands, and they are not on the same cluster of Kubernetes as that Linux VM running your Kubernetes for you. All right, let's go ahead and leave that stuff running for the next lecture, where we are going to create more services. All right, this lecture is starting off where the last one ended. So if you're just jumping into this one and you skip the last one, go back to that one, because you'll need the deployment that we created in that one to start this one. So when I do a kube control get all, I should see here that I have one deployment that has a replica set of 5, and you'll see the 5 pods. And then you'll have the Kubernetes default service, which is always there, and then the HTTP ENV cluster IP service. And you, of course, may have different IP addresses and different pod names. But that's where we need to be. So we have this deployment. We've created a IP address inside the cluster for others to access it with a friendly name of HTTP ENV, because that's the service name. But let's create one that's exposed externally on the host IP. So this would be if you were maybe in a data center or somewhere that you didn't have a load balancer you could control with the load balancer service, which we'll talk about in a minute. And you just basically, in this case, want to do a node port where you get ports somewhere in the high range of your Kubernetes cluster that you can use to talk from the outside in. So it'll be able to access it from some external service, right? It's not going to be on port 80 by default. The node ports are meant to be high port, so you're usually putting something in front of that, like an external load balancer or some automated service that will manage that for you. So in this case, I can do a kube control expose again, and it's going to look like the last one we did, deployment HTTP ENV. That's the one we need to expose, and we're going to put in port 8888 again. But we're going to give it a new name because we already have one called HTTP ENV. So this one we're going to call HTTP ENV-NP for node port. So that way it will work side by side with the cluster IP one that's already there. Then we're going to change the type to node port. So you'll notice that type of node port because the default type, which we can specify manually if we want to, the default type is cluster IP. Now if I go back and do a kube control get services, you'll see a new one there that's type node port. And let's talk about the ports on the right. Those ports, when they have the colon in the middle, are the opposite of what you would see in Docker and Swarm. The port on the left in this case is the one inside the cluster, inside the container itself that's listening. And then the port on the right is the port that's on your nodes exposed to the outside world. And you might wonder where the port on the right came from. That port is from a default range for node ports that are preset inside your container cluster. And it's a high range. The hopes here is that there's no conflicts, right? That there's nothing else on your system by default running on those ports. Because often the low ports, like 8888, are common enough that they might be used by something else. And then any ports in the really low range are usually only accessible by root, so ports 1024 and below. Now there's a few things to note here. The first one is you'll see the cluster IP. Even though when we created this node port service, we didn't say cluster IP, we said node port, these services are additive. And what that means is starting with cluster IP and then going to node port and then to the load balancer optional service, each one of them will create the services above it in this list, which means that when I create a node port, it creates a cluster IP endpoint for me because that's how it connects. It takes the connection coming into that port on the high port of the node, and then it redirects it to the cluster IP for that service. And of course, like most things in Kubernetes, all of this is changeable and customizable. One of the things you can change is the port range. One of them is you can avoid the cluster IP. A lot of that stuff you can do, but most of it you can only do in YAML, which we will get to later. When you're doing stuff at the command line like this, we're limited on the number of options we can use. And if you go beyond what those options allow, you're going to need to start doing YAML, and we'll talk about that later in the course. Okay, now if you're on Linux, this node port is accessible on localhost now. So you can use localhost or the host IP itself to curl this port. Whatever port you have, it's probably not going to be the same port as mine since mine's 32334. If you're on Docker Desktop, it will provide a convenience layer with something called VPN Kit that's just built into Docker Desktop, where it will connect this to the local host on your Windows or Mac machine. So I can sit here on my Mac and curl localhost 32334. And I get back that same response as if I curled the cluster IP directly. The reason that this is here on Docker Desktop is so that you don't have to jump into those pods like we did earlier, just so that you can access the service. This is one way to have your Kubernetes services shown up on your machine so that you can test things, right? So if you're developing or testing inside Kubernetes, you can then just do a node port and go to that port, which is going to be a little random on your host. Again, you can specify an exact port there, but you'd have to do that in YAML, which we'll do later. The other option, if you're on Docker Desktop, is that it comes with a built-in load balancer service. Now, you remember me talking earlier when we were talking about these 4 types of services, is that the load balancer wasn't built in by default, and the only way you could use it was through an external service, usually in a cloud service, right? So with Amazon, that would be ELBs and ALBs. With DigitalOcean, that would be with their load balancers. And you would need to add that plugin in your Kubernetes so it would work with those external load balancers. And essentially, the Kube API talks to their API to control that load balancer. So if you're on Docker Desktop, then you can try this command. We'll call it HTTP env-lb for this service. And we'll change the type to load balancer. And now if we do a kubectl get service, we should see 3 load balancers for this deployment. Now again, if you're on Docker Desktop, you'll be able to see all 3. If you're on Linux or using Minikube or something like that, you would only see 2. And each load balancer, because it's technically like a third-party plugin or service that's a remote API, the load balancers will all have varying features and supported stuff. You can sort of look at their documentation to figure out what they'll do. In this case with Docker Desktop, all we did is we told it the port 8888 that was a part of the deployment, and the load balancer service plugin from Docker will then publish it on port 8888. The nice thing here is that that is the one way to have your Kubernetes on a specific port outside of the default set, right? So when we did the node port, we were defined or limited to that set in the 30,000 range. And if you wanted to do something like you would with Compose or Swarm or Docker Run locally, where you just want to run it on a port like 80 or whatever, you can now with Docker Desktop using the built-in Kubernetes, you can do that load balancer and just type in that port there, and it will be responsive there. So now on Mac or Windows, I could type curl localhost 8888 and get that response back. And you'll notice there for the load balancer that it still has that other port. And again, that's because the 32 range there on mine at least is the built-in node port that it's creating. So technically in the background, remember these are 3 different layers. So the load balancer is accepting my packet, then passing it to the node port, and then the node port's passing it to the cluster IP. So there's always going to be that node port shown there next to the 4.8s for a load balancer, even though that's not really the port the load balancer is using on my local host. Before going to the next lecture, let's clean up everything we just did, and we created a lot of stuff. So these commands show you that you can use the delete command with multiple objects at the same time. And they don't have to be related objects. In fact, you could just make a big list of them if you wanted on a single command. I want to take a quick minute to talk about DNS and Kubernetes. Sometimes we take it for granted in Docker and Swarm and Kubernetes. DNS just kind of works. But I want to give you some details real quick on what's going on in the background before we keep moving forward. So what you've experienced so far is if you're in a container and you curl or ping a service name, you get back the response. So clearly there's a DNS server in there doing something to match services to DNS names. And believe it or not, DNS is optional as a service or an add-on inside your Kubernetes cluster, but everyone puts one in there. And in fact, when you install it, whether it's kubeadmin or Docker Desktop or whatever you're using, there's going to be a DNS server in there. And starting with 1.11 release, Core DNS is the default. It's sort of the standard. There's a prior one called kubeDNS, which is deprecated at this point, and we should all be using Core DNS now. So what this is known as is DNS-based service discovery. You had it in Docker, you had it in Swarm, and basically it works the same way in Kubernetes, where when you create a service, you get the host name that matches the service. But that host name is part of a larger name, the fully qualified domain name. We didn't get that in Docker or Swarm. They were really just focused on host names. But with Kubernetes, we get more options, right? So out of the box, you're just going to be talking from one service to another using the host name. But if you start using namespaces, and we will go through that a little bit later, but think of namespaces as a way to section off all the different parts of different apps into these areas inside the same cluster that won't really clash with each other. You can't technically create the same pod or the same service or the same deployment with the same names in the same namespace. But if you create other namespaces, which you may do as you get more advanced, you can then have the same things named in different namespaces and they won't clash. And that includes DNS. And in fact, when you look at the fully qualified domain name standard here, you'll see that it has the host name, which we've been using so far, then the namespace name. If you were to type out this full name, you would have to specify the namespace. By default, you've been working in default. That's the default namespace for apps. If you do a quick command at the command line of kube control get namespaces, you'll see a list here. And I'm on Docker desktop, so I get an extra one there that says Docker. So that'll be just a part of your Docker desktop that runs some special Docker services that do some of the magic that Docker provides in a Kubernetes cluster. The default is the one you're dumped into on a basic cluster, and then the other ones are standard that come out of the box with Kubernetes. The system one obviously is running the control plane. That's the system there. The public, we don't really use much. It's only got a couple of things in it. And then node lease is a new one in newer Kubernetes environments. And these are really advanced topics that you won't really need getting started. And you could quite possibly run your clusters without ever really messing a lot with those namespaces. Usually what you're going to be dealing with is the default namespace. And as you get larger, you will possibly make multiple namespaces for different applications that possibly have the same name. Or maybe you want to deploy the same thing multiple times with the same service names, pod names, deployment names, and you wouldn't want them to clash, so you would create different namespaces for those. It's a little bit similar to Swarm stacks, but there's so much difference between the way namespaces work and stacks work that I really don't want you to get thinking that they're the exact same. Namespaces is really just an organizational parameter, and it doesn't out of the box control networking, segmentation, or anything like that. That gets more advanced, and you can worry about that stuff later. So let's get back to this fully qualified domain name there. Now that you know the host name and the namespace part, then it's .svc for service, because that's what we're looking up here. And that cluster.local you see on the end is the default service DNS name given to your cluster when you create it or spin it up. And if you're using something like kubeadmin to build your cluster out, you can change that name before you build your cluster, but this is the one by default. And you'll know if you need to change it based on maybe creating multiple Kubernetes clusters, or if you've got some sort of external requirements for how your apps find each other. But again, all this DNS is inside your cluster only. It's not some DNS service that outside services are going to be able to see or use unless they're talking to the Kubernetes API remotely.